Namaskar, my dear friends. In this lecture, we are going to learn about the engineering curves. Introduction of the different conic curves. First of all, use of engineering curves. Why we are learning this chapter, engineering curves? So for that, you should know about what are the uses of the engineering curves. So they are useful by their nature and characteristics. Laws of nature represented on graph. Useful in engineering in understanding the laws, manufacturing of various items, designing mechanism, analysis of forces, construction of bridges, dams, water tank, etc. So the engineering curves are useful in number of applications in the engineering. Classification of engineering curves. First is the conic curves, cycloidal curves, involute curves, spiral curves, helix, and sine and cosine. But as per our syllabus is concerned, we have to learn only for conics, cycloidal, involute, and spiral. Okay, so we have to learn only these four curves. Now, what is cone? What do you mean by cone? So cone is a surface generated by moving a straight line, keeping one of its end fixed and other end makes a closed curve. So for example, you can see this is a curve. Okay. Now, if we rotate this line, we rotate this line by keeping this point as a fix. Okay, so it will generate a closed curve. So the fixed point is known as the vertex. You can see this fixed point on which this line is rotating is known as the vertex or apex, and the closed curve is known as the base. So this closed curve is known as the base of this cone. And if this base or the closed curve is a circle, then we get a cone. Or if the base or the closed curve is a polygon, then we get a pyramid. The line which joins apex to the center of the base is called the axis. So you can see this dashed line which is known as the axis of the cone. If axis is perpendicular to base, it is called as right circular cone. Here you can see this axis which is perpendicular to this base. That's why such type of the cone is known as the right circular cone. Now, if axis of cone is not perpendicular to base, then it is called as a oblique cone. If this axis or the angle of this axis with the base is other than 90 degree, then such type of the cone are known as the oblique cone. And the line which joins the vertex or the apex to the circumference of a cone is known as a generator. So you can see these are the different generators. So there are infinitive generators in the cone. Now let us see different conics. What do you mean by conics? A curve which are obtained from the cone are known as the conics in simple words, or we can say the section obtained by the intersection of right circular cone by a cutting plane in different position related to the axis of the cone are called the conics. Okay, so if we cut the right circular cone by a cutting plane in different position, then you will get the different curves, and these cones are known as the conics. Okay, now let us see. This is the cone, and this cone is cut by a plane which is parallel to base. Okay, so after the cutting this cone, you will get this shape. Okay, so if this plane is parallel to its base, then you will get the circle. Okay, you will get this circle. Similarly, if the cutting plane is inclined with the axis, then you will get the ellipse. This curve is known as a ellipse. Here you can say what is the difference between these two. Here the plane is parallel to base and perpendicular to axis, and in this case the plane is inclined to both axis as well as its base, and it is passing from the both side of the axis. So different conic curves are triangle, circle, ellipse, parabola, hyperbola. Now first one is the triangle. So when a cutting plane contains the apex, we get a triangle as a section. That means if the cutting plane which is contain apex means it is parallel to axis and passing from the apex, then you will get the triangle as a curve. Circle, as we know earlier, if the cutting plane is parallel to base and perpendicular to the axis, then you will get a circle as a curve. Okay. Ellipse. When cutting plane is inclined to the axis but not parallel to generator, or the inclination of the cutting plane is greater than the semi-cone angle, we get an ellipse as a section. Now here in this case, the inclination of cutting plane, which is alpha, is greater than the semi-cone angle theta. Now you can see here this cutting plane which is inclined at axis with angle alpha, and this theta is the semi-cone angle. Now in this case, if alpha is greater than theta, then you will get ellipse as a curve. Parabola. When cutting plane is inclined to the axis and parallel to one of the generators of the cone, or the inclination of the plane is equal to semi-cone angle, we get a parabola as the section. Now here you can see the cutting plane. Okay, cutting plane is inclined with the axis, but it is parallel to one of its generator. Now you can see here this cutting plane is parallel to this generator, and this angle alpha is equal to theta. So you will get parabola as a curve. Next one is the hyperbola. When the cutting plane is parallel to the axis, or the inclination of the plane with cone axis is less than semi-cone angle, we get a hyperbola as the section. Now you can see here, this cutting plane is parallel to axis and it is passing from the one side of the axis. Okay, so here in this case the alpha is equal to 0. Okay, because the cutting plane is parallel to axis, so alpha is equal to 0. Okay, so alpha less than theta, so you will get hyperbola as a curve. So these are the different 5 conic curves. Now, technical definition of the conics. So the conics, it is the locus of point moves in a plane such a way that the ratio of its distance from the fixed point is known as focus to a fixed straight line is known as directrix is always constant. Now let us understand this definition. You can see this fixed straight line is known as the directrix. Fixed straight line is called the directrix, and a line which is perpendicular to this directrix on which the point F is there. So this point F is known as the focus. So fixed point is called as focus. Now as per our definition, this is a curve, okay, and this intersection point of this directrix and this axis is known as the vertex. So V is the vertex and this is the conic curve. Okay, now if you take one point P on this conic curve, so now join PF, and a distance from this point P from directrix is PM, and distance from the point P from the focus is PF. So as per our definition, the ratio of its distance from fixed points, so that is PF by PM, is constant. So the line passing through the focus and perpendicular to the directrix is called the axis. So this line is known as the axis, and which is perpendicular to this directrix. The intersection of conic curve with axis is called as a vertex. So this point V is known as a vertex. Now here in this ratio, as per the definition of the conics, distance of a point from focus to the distance of a point from directrix is constant, and it is known as a eccentricity. This ratio is known as a eccentricity. So now see, this point P is here. So distance of point P from F is PF, and distance from directrix is PM. Take another point Q on this curve. So distance from Q to focus is QF, and Q to directrix is QN. Now as per our definition, eccentricity, the PF by PM is equal to QF by QN is equal to VF by VC is equal to constant, and it is denoted by E, and it is known as the eccentricity of a curve. Now, definition of ellipse. Now you can see this curve is ellipse. Okay, focus, axis, directrix, V is the vertex. So as per the definition, ellipse is the locus of point which moves in a plane so that the ratio of its distance from a fixed point, it is focus, and a fixed straight line is a constant and less than 1. Okay, so here in ellipse you have to remember that the eccentricity is less than 1. So PF, PM, another point Q, QF, QN. So as per the definition, eccentricity is equal to PF upon PM is equal to QF upon QN, and is always less than 1. It means this distance VF is less than VC. Okay, so in ellipse always the eccentricity is less than 1. Another definition of the ellipse is ellipse is the locus of a point which moves in a plane so that the sum of its distance from two fixed points called the focal points or foci is constant, and the sum of distances is equal to the major axis of the ellipse. Now let us understand this definition. AB is the major axis, O is the center of AB, CD is the minor axis, and these 2 points F1 and F2 are the focus of the ellipse. Now take one point P on this curve. So distance of P from F1 is PF1, and distance from F2 is PF2. Take another point Q. So distance of Q from two focuses are QF1, QF2. And distance of point C from two focus CF1, CF2. Now as per our definition, the sum of distance of two fixed points, that is the PF1, PF2, PF1 plus PF2 is equal to QF1 plus QF2 is equal to CF1 plus CF2 is equal to constant. Now, as we know that this F1A plus F1B is equal to F2A plus F2B. B. Okay, F1A is this distance plus F1B is equal to F2A plus F2B. But we know that this F1A is equal to F2B. So therefore, this F1A plus F2B, sorry, F1A plus F1B plus F2B plus F1B and is equal to AB. And AB is our major axis. Okay. So therefore, we can say this CF1 plus CF2 is equal to AB, but this CF1 is equal to CF2. So therefore, we can say CF1 is equal to 1/2 AB. So the distance from the fixed point is equal to half its major axis. Okay. So now from this equation, you can find if the major axis and minor axis are given, then you can find the focus of this ellipse. Now, say one example, major axis is 100 mm, minor axis is 60 mm. Okay, so major axis AB 100 mm, CD. Okay, now as per the definition, the CF1 is equal to 1/2 AB and is equal to AO. Now, take C as a center and AO is equal to radius and make one arc on this line AB. Okay, so this point is F1. Similarly, C as a center and AO is the radius and make one arc on this line. So you will get the point F2. So in this way, you can find the focus of this ellipse. Now, here major axis is equal to 100 mm and distance between the two focus are 60 mm. Now we have to find the minor axis. So AB is 100 mm and F1, F2 is 60 mm. So mark the point F1 and F2 is equal to 60 mm. So AF1 is equal to 20 mm and F2B is equal to 20 mm. Now, as per the definition, CF1 is equal to 1/2 AB and is equal to AO. Now, draw a line from O which is perpendicular to AB. Okay. Now, take radius equal to AO and center equal to F1 and draw one arc. Similarly, same radius, center F2 and draw arc. So, the intersection point is C. And similarly, you can find the point D. Okay. So by this way, you can find the minor axis. Now, what are the use of this ellipse? So uses shape of the main of the boiler is elliptical shape. Shape of tank in a tanker, water tanker. Okay. Also the elliptical shape. Flanges of pipes, glands and stuffing box are of elliptical shape. Shape used in bridge and arcs and shape of the monuments. And path of earth around the sun is also elliptical shape. And shape of the trace, etc. So these are the different uses of the ellipse. Now, parabola. What do you mean by parabola? So the definition of the parabola is the locus of a point which moves in a plane so that its distance from a fixed point and a fixed straight line are always equal. So here in this case, this curve is the parabola. If we take the point P on this curve, so the PF is equal to PM. So distance from this fixed point to the distance from the directrix is equal. So ratio of its distances from focus to that of directrix is constant and equal to 1. Now, what are the use of this parabola? Motor car headlamp reflectors, sound reflector and detector, bridge and arch construction, shape of cooling towers, path of particles thrown at any angle with earth. So these are the different uses of the parabola. Now let us understand what is the hyperbola. First, the definition. It is the locus of point which moves in a plane so that the ratio of its distance from a fixed point focus and a fixed straight line directrix is constant and greater than 1. So as per the definition, here the eccentricity is always greater than 1. So if we take the point P and Q on this curve, so PF upon PM is equal to QF upon QN and is greater than 1. So in hyperbola, always eccentricity is greater than 1. Now you have to remember that the eccentricity of ellipse is less than 1, eccentricity of parabola is equal to 1, and eccentricity of hyperbola is greater than 1. Now use of this hyperbola, nature of graph of Boyle's law, shape of overhead water tank, shape of cooling tower. So these are the different use of the hyperbola. So thank you very much, friends, and in our next lectures we will discuss about the different methods of drawing the ellipse. Okay. Thank you very much. Happy learning.